Hello, everybody. My name is Rupesh More, and I work for Neste as a digitalization manager for innovation organization. And today I'm going to talk about the AI opportunities in the chemical research. Um, a few words about Neste. Even though it's well known in Finland, it's something we are on an interesting journey, and our mission and our purpose is to really create a healthier planet for our children. That's our vision, and that's what we are working towards. In a nutshell, it means that we are basically into creating, combating the climate change and accelerating shift towards circular economy in our business, in our industry. We are into refining waste and residues and interesting raw materials into 100% renewable fuels and also feedstocks for other kinds of industries. We are actually the leading producer of sustainable aviation fuel and also renewable diesel. And as per the latest targets, our ambition is to really make Porvoo refinery as the first refinery in Europe to be the most sustainable refinery. Basically, in numbers, we are the kind of number one now in the world for renewable diesel provider, with a huge capacity to deliver that. And also it's worth noting that more than 90% of our current material inputs or feedstocks, what we call them, they come from the bio and residues and waste kind of category. And in 2021 already, we were able to reduce about 10 million tons of greenhouse gas emissions from our customers. And this is something, a journey that we are now into, and AI has a huge role to play in that. So how AI fits into our digital transformation strategy, that's something good to note. So our digital transformation is basically relying on three frontiers or three themes, starting most importantly with the people, wherein we have a quite a traditional business coming from a fuel manufacturer to becoming a renewable fuel manufacturer, and digital awareness of what kind of opportunities lie in the AI are very important. So really giving people the awareness and learning opportunities to understand the opportunities of AI is one part of the journey. Of course, then the question comes about, do we have the data? So building a digital foundation wherein we make the data available and also quality data and agree on the tools and agree on the kind of platforms. That's also one part of this journey. And then finally, thinking about what are the areas where we want to apply digitalization and AI and analytics in general, basically, which processes, which operations are the ones which will deliver value. So basically, our AI journey actually spans across all three pillars, from people to data to also looking objectively at our processes and operations. From AI perspective, we are into one of the interestingly complex industry domain. Basically, we are working with complex raw materials, interesting and refining chemistry to turn those raw materials into products, and that to 100% renewable products. So product design is interesting aspect for us. Then targets that we have put ahead of us are also interesting from the perspective of that we want to be sustainable, we want to bring the circularity and so on. So our ambition for AI is to really we aim to solve our toughest combinatorial and computational problems, and also see what opportunities lie in AI when we go from raw materials to ready products. It's a big value chain, and there are many opportunities in that. I'm going to talk about certain success stories and certain opportunities. We have many interesting explorations as well as proven use cases, but then it's really difficult to talk about the specific ones due to also confidentiality. But we are going to talk about some of them which are kind of very in a way visible and also kind of category wise they are kind of well known in process industry. So for first one is it basically about using AI for product design itself. So we as part of the last part of the value chain, we are into blending process, which basically blends different chemical components to create that final what we call drop-in product, in the sense that the when you as a customer go to one of our stations and fill in the fuel, it's the exact same. The behavior of the fuel should be exactly same as the one which is created with the fossil based raw materials, and the one what we are bringing with the renewable raw materials. So this blending process is very crucial process, wherein we are creating the exact similarly behaving fuel, but based on the renewable raw materials. So it's a complex process involving number of components which behave in non-linear behaviors, and computing the exact blending recipe with precise compositions has been done so far with the linear methods, but it's a really repetitive and time-consuming process. So one of the projects that we have now successfully delivered is to develop an ML prediction model using historical blending data to predict the blend recipe. And the model is now deployed in the research process in terms of a calculator, basically, which allows people, the researchers, to calculate different kinds of blend recipes without trying them in the laboratories, and test them virtually, so that they before they actually go to laboratory to actually test the actual or create the actual blend, they know the properties, and they know how the properties of the potential blend will look like. And the model would also learn from the successful blends that we create, and keep on improving the predictions. This was basically done with the cooperation with Alto, and it basically uses machine learning models of SVR, and as well in some cases. So there are multiple property calculations. In some cases, it also uses deep learning, and basically the whole project was a very interesting learning exercise, wherein we were dealing with really data which was really not exactly in the quality or not exactly in the format that we would want it, and we had to really work with the data to make sure that it's then kind of usable for the training purposes. Moving ahead, of course, this has given us interesting insights into where all places we can apply predictions in different kinds of similar processes as blending, where it involves, creating different kinds of composites and different kinds of chemical processing with the different kinds of components. The other example I would give is that basically this is something on the similar lines as maybe Arto was explaining also. This is about the kind of a predictive maintenance category, wherein one of our, or let's say, as you might have seen on the left, what you see on the left hand side, in the production units, we have those processing units which are large, and which basically have really extreme conditions inside them, and these run for months and even years, creating being part of the refining process, and uh, having really crucial part in the whole process. So one of the problems that we face is that the uh, many of these tanks, they accumulate fouling layers inside, which is a substance which sometimes blocks the process, or which sometimes becomes a hurdle in the refining process. And the only way to kind of get around that is to have preventive maintenance to stop the process, and really remove the substance from inside. And in these situations, because the conditions inside such units, it could be hazardous, and it could be extreme conditions wherein temperatures could be in few hundreds of degrees. All the monitoring technologies related to the sensors that rely on temperature or anything else, they don't generally work. So we are on the, let's say, we have to rely on the data that can be collected once such a maintenance is happening. So the idea was to kind of think about how can we do bit more predictive maintenance, or how can we understand what are the variables that impact the fouling layers. So this was a very interesting exploration project in which we developed a machine learning model, which we trained on the sample data which was collected from these fouling layers during the preventive maintenance, and that was used to predict the process parameters, the variables that impact the formation of fouling layers, and that showed a good correlation between the variables and the actual formation of the fouling. And this is something then was utilized to further develop the preventive maintenance actions a bit more accurately. And we are continuing the journey with trying to understand how do we really go from preventive maintenance to predictive maintenance. But this is one of the cases that again applies. It's a big category. There are different kinds of units, different kinds of equipment in the labs, in the refinery, which have different kinds of foulings and faults, and often not in all scenarios you can apply sensors which can in real time read the conditions and so on. So you have to rely on some sort of predictions that could be done on the data that is available. And these are some of the toughest problems that we are working to solve. Then going from there to finally to more like a category which we call it an opportunity. So AI driven. This is again something similar to the previous presentation. Was it by Arto? I think similar to that. So AI driven assisted design of experiment. So basically the problem is that in our field, when we are working with entirely new materials and discovery of molecules, and trying to understand, find new methods to treat interesting feedstock into fuels and intermediate fuels, we are operating with a generally large experiment design space, wherein the researchers they currently currently basically use identify a large number of experiment candidates that are need to be done in the laboratory in the physical environment. And in the laboratory, the experiments are then carried out, and the prioritization is based on, of course, the human judgment. And this process to get from to find a specific method to treat a certain material or to break down certain molecules could be very expensive and time consuming. And this is where we see an opportunity where this design of experiments could be assisted through AI. So obviously, over the period of years, this uh, physical experimentation and the current way of working has generated a lot of data in terms of the how the experiments whether they passed or failed or which of the candidates actually gave us the ultimate process route or ultimate method that we were looking for or composition that we were looking for. So along with the kind of inputs and outputs, we do have the research data there. So the idea is that we would be training using that data certain machine learning models that could help us in designing the experiments. In the sense, the model could be trained using the data as well as alongside the researchers who would then kind of contribute in training that which methods were selected eventually, or which experiments were selected, and along the time this could be used as a suggestions from the AI model, that the AI model could gradually then start prioritizing the experiments along with the researchers, wherein instead of kind of, let's say, if we are currently identifying 50 or to 70 candidates or more than that, the AI model, we are expecting to identify the top 10 candidates which could be tried physically in the laboratory. And as well, at the same time, it could work in a fashion that depending on the results of the first few experiments, it could suggest the next experiment and so on. So it's really kind of optimizing the selection and prioritization of experiments to really reduce the physical experimentation. So this is the kind of area where we are exploring that how AI can assist. And currently, because at times we could be also dealing with the entirely new materials which doesn't have data, and then we could be dealing with the materials which we have been experimenting for many years. So we are working on the concept that which all places, what all data we have, and how to start to select the first use case, which would then be the case for starting to explore this AI-driven design of experiment concept. To summarize, basically in chemical research industry, whether it is for a company like ours who's into producing sustainable and renewable fuels from interesting new raw materials based on bio and wastage, or into any other industry wherein, for example, drug discovery and similar. There are plenty of opportunities. One of the reasons I see is that the complexity of science which is involved when you're dealing with combinatorial problems, wherein the permutations, combinations, number of them are huge to be tried out in the physical laboratory, and a large amount of data is being produced anyway as part of the experimentations and chemical processing. And there is huge potential for competitiveness in this industry. The one who can find the value delivering use cases can get the really speed of innovation, speed of product design, and that's where one can get the company can get the competitive edge. So there is plenty of opportunities. Examples besides what I've just given, AI-driven experiment and product design, of course, discovery of novel materials and feedstocks, and one of the interesting examples that we are also looking into is the traceability of supply chain. So we are into a big value chain where we are getting different kinds of raw materials from different kind of suppliers, and we also want to be sustainable across the whole value chain. So how can we use AI to have that traceability, to measure that quality, and ensure that the whole value chain is sustainable. So these are some of the examples and challenges that we are exploring AI with, and will be doing for next few years to come. That's all was my presentation.